Gadget UK here again. In the previous part we identified a power problem, swapped out a regulator with an alternative one. We got the board up and running. I broke the screen myself accidentally, so there's a crack in it. But we had no sync when we tested it on the MSX, and I tested the various devices. Not only that, we had nothing on the screen, like no on-screen display. This should give an on-screen display, and there's just nothing, a black screen all the time on the right HDMI channel. Right, so it might not be the fault, it might not be the only fault, but I'm going to get that off anyway, because, well, there's nothing else we can do apart from wait for the chip. So a larger nozzle would make more sense here. But anyway, I'm just going to go around and round and round this. There we go. Yeah, it's heat sunk in the middle, look. That's what made that hard. Yeah, be careful in case any of the things on the underside are molten. But you can see there, there's no damage. Right, just going to mop up the solder here. I'm curious to see how this behaves without that chip. I'm going to do that next when it's just cooled down a bit after we've mopped up the solder here. Whilst everything looks like it's not bridging. Oh god, this is really difficult. It's that same thing again, like no clearance anywhere. You've got loads of heat sinks and connectors. Obviously putting these chips on at the start when you're assembling one of these might be, well, would be the easy thing. But not when you've got everything on it. All the connectors and stuff, and the chips heat sunk, etc. I'm pointing you down so you can see what I mean. You've got the iron here, you've got switch here, you've got connectors here, you've got heat sinks here, connectors on the back. Trying to rework a position like that, it's not as easy as you think. Just being gentle here. What's that there? Is that a bit of solder that's removed or a white mark? I don't know. Silk screen. I think this might be a no fix, you know. I think I've just got this feeling. I've got this feeling I'm going to spend ages putting a new chip on and a new screen, and it's like, it's still not going to work. I'm going to get another chip for one of the other ones, and another one, and then go, oh my god, it still doesn't work. I wish I'd never started looking at it. I think it's worth the money we spent on it anyway, just to try it. If it works, great. If that doesn't work, I don't know, I may give up and use it for spares or something. Just because we'll end up building one, you know, if we have to buy other chips and things for this. Well, they're not cheap, it'll be another 20, 30, 40 quid or more in parts. Right, so I see no shorts there. I'm going to try it now anyway. I'm just curious, like, how does it behave without that chip there? Like, will it give us a display on the broken screen there? That's all I'm curious about. If that still works, I'd feel a bit more positive about there's a chance with this. If it doesn't, there may be that it just controls that. And that's the thing. Oh, error. Error 3. Oh, that's interesting. So, yeah, that has some bearing there to the boot up, because we're getting an error 03 now. Well, there you go, you learn something every day. It looks pretty dirty and horrible around here, but anyway, we'll wait now. I'll put that on the side. We'll wait for the chip and the screen to arrive and pick up then. Right, a week or so later, the new screen has arrived. Looks correct, looks identical, doesn't it? Which is bound to do. It's got the same manufacturer part. It doesn't look like a clone, it looks genuine. Anyway, so I'm going to get that screen off. You could argue replace the chip and then do the screen, but, well, it's just the order of things have arrived. And what I'll do is stick some bubble wrap taped onto it, so just so I don't scratch it up and break it again. Because the thing is, I'm not sure I explained it very well, but, you know, all I did is I lent like that. Just a tiny bit, not much, and it went crack. I can't believe how easy it broke. It's like, literally, it was just a little press like that. There, crack. And about that hard. It wasn't hard. I'm actually amazed at how easy that broke. There's 2 solder contacts on this side here, and all these ones here. I think I'm going to mop those up with some braid to start with, just to maybe try and make this as easy as I possibly can, I think. Oh, I don't know, we seem to be achieving it there. If I just cut the braid back, just give it another pass. They feel like they're floating off a little bit. I can maybe just, as I go along the line there, just try and bend them up or something one at a time, or something like that. With the flux, without the flux, the capillary action will be crap. And not all braid is the same. Some braid contains flux. My advice is get that if you can. Up. Sticking in the wrong place there. It's what interesting is watching the heat go up and down the pin there. Doesn't really matter if we have to wrench this thing off, because, well, as long as I don't lose any pads. The point is, you know, an odd wobble like that. Yeah, you can see the pin moving a bit, I think. There probably is some solder underneath it. Yeah, but it's now a case of just trying to free this up. I know you can't see what I'm doing here on the microscope. I'm just looking at those connections just to see, well, see what I can see. And as I press this that way, which will damage the screen further, just going to see. Yeah, and what I'm going to do here is press like that and heat and try and free the pins up here, because, you know, if I push the screen, they're not moving. So you know what, that is stuck down. No, it's not. Hang on. No, it is. Pressing. Yeah, it's up. 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 You heard it. Up. This is not the way to remove a screen if you wanted to not damage the screen further, is the point. Up. There we go. It's come off. And you can see what I mean, it just folded straight over there. Look, it's got worse, look, as a result of that pressure. Which is you know, it's bound to do, isn't it? It's absolutely bound to do. So, here, yeah, it snapped off there, that's why that's got worse. This point here is still on there, but it broke on the actual screen itself. There we go. So yeah, there's nothing we could salvage on that anyway, and the crack in it meant that the LCD was totally gone. So yeah, anyway, I'm not going to lose any sleep over that. And the leg here broke off as well, look. Yeah, you can see that, it's still there. I'm amazed that it just snapped off so easy there. So let's just make life for ourselves slightly easier here, hang on, if I can, by absorbing a bit of solder just to make it go on nice and flat. Same over this side here. I hope the screen works after all this. It came relatively well packaged in you know, an ESD bag and in a box, you know, a container, so that it wouldn't be damaged with foam. I'll show you, it's in the thing at the moment. So as long as it wasn't a faulty one, or have some sort of manufactured defects, then it should be fine. Let's get the new screen on. So it came in this, which was inside an ESD bag, and it was taped. Vacuum pen must be used. A vacuum pen to assemble that, really? Right, so I've got to be really careful with this now. Yeah, so it looks like you've got to sort of slide it on that way, because there's little plastic wings here, you know, little things, you know, that correspond with those, so the PCB goes into like a little channel there. We'll leave the protector on like it had on previously, and just leave it there. And we need to slide it that way, so just have a look here. Those look alright. We're going to resolder that in a minute, obviously, and but I'm not going to remove the flux from that because there's no point. And then what I need to do is try and get the metal contacts on the top here. I might need to use magnification to do this and try and slide it on, but we may need to gently just move the odd pin down this way, because they look like a few of them have just been bent upwards slightly. And if you're wondering what I mean, you can see here, like that pin is hanging down, so I'm just going to just gently press up like that. Well, let's see if I can somehow attach that. Yeah, I'm glad I checked there with the normal magnifier. Unforeseen. I couldn't see it. Can you see that? Look at the size of that lump of solder on the end there. So that was blocking it. It looked like it was, the pad was free. Or, you know, free of solder, that is. But, well, clearly it's not. It's got a giant lump of solder on the end of it. I think. That's it. Or is the pad folded there? I don't know what's going on here. It's like a giant thing stuck up. Yeah, I think that is just solder. If you find these videos useful, please do consider subscribing. If you'd like to support the channel, see Coffee and Patreon links down below. Yeah, looking at the old screen versus the new one, see these little notches here? They're missing on the old one. Someone's cut those off, because otherwise, you can see, it sticks on the PCB. We can't get that extra bit of distance here just to push this slightly further in. But this doesn't overlap on the PCB. I thought it did. I thought it had a, you know, sort of shape like that. I went push on the PCB. It doesn't. It just wraps over the screen. So I need to remove it again and just pull those little notches off. So if I just gently try and slide this off carefully like that. I think actually, rather than use foil on them, put lots of physical pressure, I'll just use the grinding pen. Just because I'll have to do it carefully in a controlled sort of way here. Just try and get it flat as possible like this, and then just go. Yeah, it's sticking up a bit, I can feel it. I think that's it. You see, the thing is, as I'm doing this now, I know I'm doing this wrong. And what I mean is, I should do this last. Because they're going to be handling this with this thing. Oh no, I'm going to bleeding break it again. So I'm going to use the power connection here from the Mister. It's the same polarity I was using this before. So I send a positive 5 volts. Yeah, be careful not to press the screen. And let's plug that in there. Switch it on. Yay! The screen works. You see that? Now switch it on. Init error -3. That's what happens when you're missing that chip there. So at least the screen at the moment is functional again. Alright, so I cleaned up the solder points around the thing. You know, on the underside, I used the toothbrush and went a little inch down this way and just brushed this way down carefully. Just tested it, it works perfectly. So just while I'm waiting for the chip, I think what I'm going to do is just going to wrap around there like that, and then just simply tape down onto the PCB. Yeah, and the interesting point with these screens, the failure points, you know, we had the crack here, and then we had a crack there when I took it off. And obviously they're perfectly aligned with the edges of the solder points there. You know, so it's once that's soldered on the board, you just need only a slight bit of pressure. And because the glass is like pressed right firmly against these pins, this is why it cracks like that up there. So yeah, that's a bit of an Achilles heel on these. Certainly on the OSSC, I can imagine if you just dinked this screen from the front, unless there's a glass or plastic cover to go over that, just the slightest dink, and this is where you're going to get these cracks like that. I'm tempted to try and find some sort of protector to go in there. Assuming there isn't one on it, I don't remember seeing one, to be honest. Right, so after about 2 weeks, a chip has arrived. One chip. It was about £8, I think, with about £8 shipping, which is not the most cost-effective thing to do. I should have maybe gone DigiKey and ordered 3 or 4 of these, maybe. Certainly more than one. I mean, DigiKey, you could order one and you'd be a very high level of confidence that it would be okay. But this was from AliExpress, so hopefully it'll be okay. So we've also got fuse. I ordered a new fuse. I nearly grabbed the screen there. I'm glad I put that bubble wrap around it. So I've got to try now and implant our new chip here. So yeah, I am not looking forward to this because the pitch is so fine on this chip. We'll cut over to the microscope again in a second, I think. Just get that out though. And I need to untape this thing, don't I? Yeah, it's like I say, I've been thinking properly about this, and I never think properly about anything. I would have not fit that screen until we got the chip on. So I've seen a bunch of repair logs and videos and things over the last few weeks since I did this. One of them will be on Philip's channel. I'll post a link down below. Check his channel out. He's a really good guy. I think he's based in the Newcastle region. Might be Sunderland, I don't know, somewhere in that part of the country. But he's an amazing guy. And he did say to me, actually in my Discord, Chris, you should have told me. I did mention, I think he mentioned to me previously he had some of these chips, and I didn't realise. I thought he'd had the larger chips, I don't know. And I think he may have all three. The point is, though, he's done a repair on one of these, and you know what? He's got almost identical type failure. The regulator on the 3.3 volt rail being the thing that fails. And that's the thing. In the repair logs and other videos that I've found since I started looking for things the last 2 weeks, it seems to be a common failure on these. So you know what? The regulator that I've fitted on there, I'm going to leave it on. A bigger footprint regulator that will handle more current and dissipate the heat better, in my mind, is better than, and I'm not being critical of Philip here, is better than replacing the regulator, you know, for one of the exact same family, footprint, etc. You know, the size of the component. A bigger regulator is better. So it does seem like a very common thing. One or two instances, it's just the fuse. One of my guys in Discord was like that. Has that got flux on it? You know what that has? That's come off something, hasn't it? Ugh, it's not going to, it doesn't bode well. I mean, it may have been tested, but I don't know. If this doesn't work, I'm going to be really cheesed off at the seller. Yeah, TVP 7002. I mean, it may be that they're making more money by taking parts off boards like this than ordering direct from DigiKey. I need to try and find pin 1 now, don't I? Oh my god, where's pin 1 on that? Oh, it's there. Little circle down here. Yeah, then try and anchor it. Very tight space to work in here as well. I'm not going to get any flux on just yet until I've anchored it. And then I'll probably swap over to the Antex just because it's got a chisel type tip. So, this is going to be the hard bit, to try not to move the darn thing. Or more than one pin maybe. So that looks alright. Let's now come up here. Those sides look okay, I think. And let's try and do the same thing up here. That'll do. So it's looking pretty good along there. Pretty good down here. And on that side. We lost a bit of solder mask there, look. And it's okay here. One thing you do get, certainly when the chip's been removed, you can see here, like that pin is slightly right aligned. So you can, you know, just come in and just press the odd pin just slightly. You know, if it just looks like it's sitting to one side further than the other, you can just give it a slight press. Not something you would need to do with a brand new chip. And some of that can be an artifact. You've got to be careful, an artifact of which angle you're looking at the thing. But they're all looking pretty good. They're looking pretty good. Yeah, and they're looking pretty good, but it's the same kind of thing, where just one or two of them just need a slight press. Not much. Like down here, these, the ones on the edges. And typically you'll find the ones on the edges are common when something's been taken off the board. Just because it gets a bit of leverage in the corner. Yeah, brand new tube of chip quick flux here. And let's get some flux down here. It isn't the best type of application, this, because it's got, well, I'm putting a lot on there, as you can see. One with a tiny little syringe type thing would be better. Got to be careful with the screen here. I don't want to stress the screen out at all. And it's going to be quite tight because of all of the components in there, isn't it? You know, all these resistors and caps and things around the outsides. Right, I've got this thing nearby, always handy. So if I use that now to just clean up the tip, and we're using the Antex here, I've got to be very careful with the screen, which is to the left here. And I'm going to try and introduce some solder here. Yeah, I make a mess. So I've got enough solder there, I think. Let's just now try and distribute it with the iron. So little space. I might need to remove that crystal. Just dragging slowly here, as you can see. Let's get a little bit more solder. 1 or 2 pins like there, where I was at that point, sink heat. That tells me that's a power or ground probably. So you may need higher temperature and slightly longer, there we go, to pass that heat. This particular iron sometimes takes a while to warm up, but well, it's had a few minutes. But it might get hotter yet, is the point, because it's not temperature controlled the same. But I like using this iron for this kind of thing because of the shape of that tip. I'm looking for the wave of solder. Can you see there's like a little bead? I think we've got just enough there. Maybe not enough on those end pins. Right, let's just clean the tip. I think what I'm going to do here is I'm going to use a cotton bud. I'm just going to squash it down, and I'm just going to try and redistribute the flux that's presently sort of all down here on the actual pins, rather than add more flux. It might not work, it might work, I don't know. Let's just give it a try. So I get this onto there and sort of just try and distribute it up this way a bit. I mean, as that is now, I'm sure that'd be okay. I don't really need to reflow really, but well, let's just give it a reflow anyway. See, like, there you go, it's just the odd solder point that don't look so hot, if you ask me. So I'm doing the side here that's facing the screen. The screen is down at the bottom there, so I've got to be very careful here. The crystal's down this side here, so I'm probably going to only be able to get so far across. They're going to have to rotate around to finish the other side, and the screen is at the bottom of where the magnifier is here. But we've got a nice exposed area here, so if I'm able to get flat and flush, I might be able to drag like this. Bridge at the end there, I can see it. Those 2 pins, there you go. Yeah, everything apart from that 4th one looks alright there. Some of it is probably a trick of light. You know, the solder can look weird when you've got all this flux on it and you've got light from different angles and things like that. Anyway, I think that's it. I think it's on. So I'm now going to clean it with cotton buds. Like, what's that? That's something that needs to be dealt with, isn't it? I actually think that was the exposed trace, wasn't it? And it just happens to have accumulated a giant blob of solder. But you see how close that is to the traces nearby? There's no short, but what you may get from things like that is inductive coupling. So yeah, anything like that we need to deal with. I've got this feeling this is not going to work, you know, like they sent me a duff chip, or I don't know. There may even be another fault. This might not be the chip that's faulty. It's just that the fact it's on the 3.3 volt rail, we know the 3.3 volt rail expired. Yeah, it's kind of logical that this would be the thing. And what's the sequence of events? Yeah, did the chip kill the regulator, or did the regulator kill the chip? Well, I'll tell you now what my opinion, honest opinion, is the regulator died and then the chip died. That's what I think. I think those little 3.3 volt regulators on this design, they're not kind of up to the job. Now they are in terms of the current rating, because somebody, if you look at I'll show you a page of the schematics, you can see all the voltage rails, someone's calculated the current, how much current should be drawn, and the regulator is up to the job. It's like more than 100% more capability than the amount of current drawn. But the thing is, it's such a tiny component, and these three main chips are all heat sinked. That tells you everything you need to know, that there's quite a lot of heat generated, despite the fact the regulator is appropriately sized in terms of its milliamp capability for the job in hand. But what it isn't is sinking heat properly. It's too small. It's way too small, I would say, on those little regulators. If you're going more than, say, 10 or 20% the current that it can provide, don't fit one that size. If you're going over 20%, say, fit the next size up. Yeah, back on microscope there, if we just move that into position. That doesn't look bad. Doesn't look bad at all. Still a tiny bit, trace amount of flux there. And it's the same thing I thought when we were actually putting it on there, where I'm like, is there any solder there or not? It kind of looks like there is, but there isn't. So I'm going to have to try and reflow these, I think. I don't know. Can make a right mess of this, so I can see it coming. Right, I think I'm just going to give it a go. That's like I say, I've got low confidence here. I really do. We don't know the state of that chip. Maybe it did work before someone took it off something and it doesn't now. Maybe I have a short there somewhere. I don't know if that's on or off. Switch it on. It's on, OSSC. Switch it off, let's just test the top of that. Stone cold. Switch it on. What's that say there? MRARQS. It's alright, stone cold. I actually think that might be fixed. But, have we got video? Let's just connect HDMI up. Don't work on a bench this size. Alright, I'll get the TV on the right channel. I'll be so pleased if this works, but again, I'm not overly confident. Because, well, if one thing dies like that, something else could. It might not be the only thing. It might not be the only thing on the 3.3 volt rail there. I think I had a quick look at that, and I think I was convinced that maybe not much else used it with that particular regulator. But I don't know. I'll find out. So, TV's on, switch it on. Come on, work. Please work. Please work. Nothing. So, that's not good, is it? Why have we got nothing? You think something should be coming up there. I'm wondering if this is like set to 1080p or 4K or something. My screen can't display it. But we're not getting the grey thing. You should have a grey thing. Do you need an SD card in it? This is the thing, hasn't it got an SD slot? I think it has. I don't think you do. I think that's just for like firmware updates and stuff and settings maybe. But why are we not getting anything? HDMI is definitely in. Maybe the HDMI cable's bugs. I don't think so, it doesn't look it. You see, this makes me think the original chip was on there was alright. That isn't the issue. So I may be one of these chips up. The original one might be alright. I'll try pressing one of these buttons, I'll switch it back on. And we'll see if any of those do anything. No. I'm going to switch that switch over there, see if that does anything. No. Maybe it takes some time to boot, that's the thing. Like maybe it doesn't just instantly come on. So I'm going to finger touch those things, switch it on. And just see if anything happens over a period of time. So I've got the TF-MSX here plugged into the SCART. Let's power the TF-MSX. Right, that's on. Let's now switch this on and see if anything changes at all. We'll have a look at inputs maybe. I've got how you do this now. 1, AV1. Oh, it's got RGBS now. It's showing it there, but there's nothing on the TV. I think. Yeah, no sync. no sync. Press the first one again. Yeah, 262p, 15.69 kilohertz, 59.91. This is different. It's actually detecting the RGB now. That was not happening before. But we're getting no HDMI, so I don't know. Maybe the chip here. Maybe there's like an extra fault with this. There's more than one fault. But we didn't have the sync being detected until we replaced this chip. So it's certainly more than one fault going on here. Nothing getting hot. Yeah, definitely more than one fault. Pressing those buttons. Oh, that changes your channel, so we can see no sync, no sync, no sync, no sync, and then we get the sync. So it's doing more than it did. I'll try and reset the TF-MSX. We're just getting no HDMI output. Yeah, no HDMI output. I wonder if this output's 1080p, not 720p or something. The TV can't handle it or something. That's a possibility. It might now be fixed. I don't think so, but it might be. I'm just going to bring this ruler down here, and I'm just going to press some of these connections there, just in case we've got like a bad point or something. Yeah, don't move sideways or anything, but sometimes just doing that can help you work out if you've got a dry solder joint somewhere. And on the HDMI connector, nope. On the filters, nope. And to a degree on the port, just have a bit of a move around carefully with it. Nothing. I don't know. Don't know. All we do know is that this is different now. Yeah, so nothing on the screen. I've tested on another TV as well, just to rule out it's something to do with the, the HDMI mode or something. Let's just test these. I reckon these should be filters. We should have a join. Why are they joined together? That could be a fault. Because, like, why is that first pin there? Right, it's joined across. It's joined across there as well. Those two are joined to each other. That doesn't look right to me. Those aren't joined. Let's try this side. Those are joined. Maybe that indicates there's a short on here. Or maybe it indicates that there's a problem with the HDMI connector. Hang on. Yeah, so there's issues here. That those two seem to be joined, those two seem to be joined, those and those. Let's try this side. I mean, maybe the filter component's the fault, but maybe not. Maybe it's this chip. Hang on. Same here. I'm going to measure on resistance in a minute. Maybe these are... There's something specific about these. It's like it's a pair of connections that... I don't know. I'm confused. Let me put the meter on. Ohms. I know you can't see what I'm doing. I nearly smashed the screen there with the meter. That was nearly a bad day. Alright, let's try this again. I'll tell you the reading on ohms. Hang on if I get the probe in. Right, 0.7 ohms to that one. 68 ohms. I feel a bit happier now. That one. 0.7 ohms ish. Hang on, it's wobbling all over the place here. It's like, yeah, 0.6, 0.7 ohms. That one. 68 ohms. I'm happy now. I think there's going to be a pull-up or something. It's like 68 ohms or something. So the fact they're not a direct short, like that one's 0.7 again. That's 0.3 to there, 68. Yeah, it just gives me confidence that there's not some major fault there. 0.5, 68. So, yeah, I think the output side here, it's unlikely that's a faulty. Those HDMI connections don't look great, do they? Unless I've had just a gentle prod. If I can get the angle right. And you can argue the probe is a better thing to do this with. Yeah, there's nothing there. What's that 2 there? Is it a fuse? I don't know what that is. 2 amp maybe. That'd be so funny if another fuse had blown. No, it's not that. I think that's a fuse. I could be wrong. It's not marked, is it? It maybe is. Oh, there, F upside down 2 is a fuse. Well, it ain't that. I don't know, it could be anything, couldn't it? It could be anything. Oh, that doesn't look so hot there, what's that? It's Jasper fur is what that is. And it's finally just died. I was scoping it and I'm like, why am I getting a tingle from there? It's to do with how it's powered. I didn't even have a ground connected. Maybe that's the problem. Yeah, all I was trying to do is scope the crystal. As soon as I touched the crystal point there, the display went off. And I switched it back on, nothing. So I'll show you this now. Nothing on the screen. And both these LEDs on. Something has died as a result of just scoping that crystal. That's hard to believe. It's something to do with that power supply that I'm using. I'm not sure what's died here now. Probably the FPGA, I think. That is so annoying. I mean, I'm tempted to scope that crystal again, but maybe the crystal died. What frequency is that? Because that's what I scoped, the crystal, and then it went off. 27 megahertz. I'm going to remove that crystal, I think. Yeah, I think on this particular occasion I am going to give up with this, and there's a reason. I know I can fix this, right, but it's the cost. It's just not worth it. I've replaced this chip already, yeah, and we obviously had the menu working. It was detecting the sync, which was an improvement over the start. Still wasn't outputting HDMI. I think that's this chip. This chip here is an FPGA. You can program it with the JTAG connections here. I think, just looking at the routing on this, because I was probing the crystal, and I follow the crystal, it goes down to a wire down here, it comes up underneath, and then it comes to the chip here, it goes to the FPGA. That 27 megahertz crystal's going to the FPGA by the looks of things. I actually think a voltage issue with this power supply here, and not using an isolation transformer, just connecting to the output of the clock there, raised the clock level like by like half mains potential or something crazy, which killed the input pin on the FPGA. Now nothing's getting hot, it doesn't do anything. I'll show you, I'll switch it on. It just doesn't do anything. Both lights on, it's like it's not booting, it's not getting off the start. Yeah, there's a chance it's lost its code, but how would it lose its code? That doesn't make any sense to me. It's more likely something's failed in that FPGA, but nothing's getting hot. My guess is this is not faulty. I reckon we could take that off and we'd still get a blank screen like this, because I think this is bugged. But we know this is bugged because we're getting no HDMI. I honestly don't think there's any value. We've already spent 20 quid on a screen. We spent 20 quid on a chip here. We're at 40 quid already. By the time I've got an FPGA and I've got the chip over here, I may as well buy another OSSC. There's just no point. And those things aren't guaranteed to fix it. In other words, when this died, and I'm sure it has, it may have killed this again. So I may need to go and get another one of those as well. I just don't see any point. I think just take this as a lessons learned thing, really. That often on these the fuse goes, and that maybe the regulator, if you do swap the regulator, put the beefier one on there. If you're unlucky like I was here, I think this may have gone. And if you're really unlucky and you try and scope something, and then the power just goes off the minute you scope a signal, yeah, chances are you're going to kill something on here. It could be, you know, the specific issue I've just had with the scope. I've never ever had that before. It could be this Taiwanese thing here. I'm using the DE10 Nano adapter, and it's one of these power supplies that can switch between 110 240 volts automatically. That might be something to do with it. It's like a floating level somewhere, and I didn't have the grounds joined up. You could argue if I had the grounds joined up, I may have killed the scope. I think I'd rather kill this than kill the scope. But yeah, I'm out of ideas really, other than spend a load more money on potentially 2 or 3 new chips. I just don't see the point. It's better to sell it for spares, I think. It's annoying though, because, you know, if I'm honest, I don't think these things are very well designed. These piddling little regulators, there are always going to be a failure point on these. Yeah, it's no surprise. These three main chips being heat sinked here, it's no surprise because it's, you know, in a confined area, they're going to overheat. I actually think this should be redesigned into a board that's like 50% bigger to give 50% more space and have a fan somewhere in the design and beef these regulators up to the one size higher or maybe even more. It's so annoying that scoping one pin could kill it like that. I didn't short anything. Right, before I completely give up on this, and I am at that point really, it's rare for me, but I know I can fix it, I just can't be bothered with the cost and everything. But before that, before we completely give up, there's just one final thought I had, and I was just looking to see, because I thought this had died, maybe, yeah? 27 megahertz going there, it doesn't, it goes to the 7002. And actually looking at the schematics, you can see it goes to the FPGA, the 27 megahertz, and it also goes to the TVP 7002. It may go elsewhere as well, but anyway, it goes to a few different places. Now the fact it's not doing anything, I'll just show you this one more time here, that it doesn't do anything. I'll switch it on. Nothing on the display whatsoever. Red light on. It's like it's not even booting. So I mean, the FPGA could be dead. You're thinking it could have lost its code. How could it lose its code? Just, you know, if there's a voltage issue on a clock pin, I can't imagine that just going, oh, darn, I've lost my firmware, I don't remember what I was doing. I seriously doubt it. You've got to have a specific instruction sequence of, you know, things going across commands on certain pins to be able to change the firmware. So anyway, I'm going to put some low melt solder all the way around here. I'm just going to remove it with low melt. And I'm going to try it without it. If it suddenly springs back to life, the display, we know it's because the clock pin. Hang on, I better just make sure I'm not smearing over the resistors there. Yeah, the clock pin may have taken offence on it, and it's just sat there in a state of I'm not doing anything because the clock's not going to it. Does that make sense? Right, let me just clean up with some braid. I'll show you the underside of that in a minute. It looks mysterious. It looks alright. Alright, let's give it a try. Bear in mind that I just touched the plastic there with that. If there's any chance now this will come up with -3, error -3. If it's not, yeah, it's dead. FPGA is dead. Oh well, what can you do? But like, how does that kill that when the clock ping is like that? You know, this is the thing. Oh well, that's the end. That's the end of that. Because there's just no point. It's like I know I could fix it. I could get that's probably all right, but I doubt it because that, you know what, that's connected to this, and that's what we scopes, and that's what eventually, you know, actually killed it. It died as a result of scoping the clock output here. So I think it needs one of those, and one of those now. That's going to would be a pain to program up. Yeah, you just use JTAG, but you're going to get the right version of the software and stuff, and I think there may be a license involved in that. It could be one of these things where you can do it for free on a certain version of the software. It's just a lot of trauma and cost. What's the point? I mean, I've already, you know, like I said, touched that. I wouldn't be surprised if I got it all back together now and found the display wasn't right either. I mean, in theory, it could be the display that's dead. Maybe this is half working. If we'd left that on and replaced that, maybe it would work, but we wouldn't have a display. Maybe it needs another £20 display. I'm just giving up. I've had enough. It's rare for me, but yeah, I have had enough. I'm not going to let this suck any more life out of me. Yep, and I've had a good measure around with the multimeter. Voltage levels are alright, ferrites are alright, fuses are alright. Anyway, do check out Philip's video down below. It's just an example for you about how some things can be quite hard to work on. You know, I destroyed the screen just from pressing it like that, just catching it on a corner very gently. And then, well, it went downhill from there, didn't it, really? We worked out the initial fault, the regulator, but because the regulator had shorted, 5 volts was passing across, it had killed that, because we know that, because even though we had the display up here, when you chose AV1 and I connected a source, we never saw a sync. It said no sync. There was no sync. It wasn't detected sync. We replaced that. We got the sync back, but we still had no display. That's going to be that. Could have been this, could be that still. That might be alright. There could be some reliance on the HDMI, you know, the signals of video coming through to this to output some video. So it might, you know, it might just be these 2 chips now. That might be alright. But, well, it's a load of guesswork. Very hard to work on. There's very little space in there. My advice to anybody working on one of these is, if you are going to work on this area here, or in the board in general, if you get in a display on the screen, you know, on the TV, remove this thing. Just remove it until you're finished. Yeah, not much more to say, really. What a nightmare that was. Right, it sprang back to life. Just as a last-ditched attempt, I thought, let's try JTAGing it. So I did a bit of research. You need a USB blaster. We modified this as part of a previous video for the SD-Mac. And I connected it up, powered the device. We had nothing on the screen. I went into the Quartus Prime software, programmed it with 0.85 firmware. It said old, whatever that is, I don't know. It might be the wrong version. And if I show you now, if I connect up the power supply here, yeah, I'm pleasantly surprised. This is what I was hoping when we removed that chip, but we didn't see that. I switch it on. Init error 3. It's working again. So it's not completely toast at all. It lost its firmware. So I now need to get this blooming thing back on, don't I? Because I'm sure that chip is alright. So I'm going to desolder braid around that, not show me fitting it, and just show you it back on there. And then I'm going to take up the offer from Philip Bryden for the chip over here. Assuming the FPGA is not the issue here. Maybe there's a chance for this. I'd literally given up. I'll report back. Right, so the miracle thing. Initially I had an init 3 error again. And I'm like, oh my god, maybe that chip's dead. And then I thought, I'm going to reflow the connections down here. And that just solved it. Actually, it did come back to life, so I've switched it on. Now it comes back with everything here, 0.85. I'm not sure if I've increased the firmware there or what. I just went with that firmware. We can upgrade it later to one of the latest ones. You have to do a wire mod to do that. But anyway, we seem to be no worse off than we were. We've got the menu. We can, I think, go in and out of the menu. Yeah, we can. I'll do reset settings. I should have pressed down, not up. There we go. Reset settings. Done. Yeah, just the same thing. No HDMI output. So I am going to contact Philip now and see if he can send me one of those chips there. Because you never know, that might actually fix it. I mean, I'm having a hard time understanding how something on this side from the 3.3 volt killed that. Yeah, that makes sense. But then how does it affect this? Yeah? I don't know. And I'm even more confused that I scoped the crystal and it lost the firmware. How does that happen? How did it even cut the power? I don't know. I thought that it killed the FPGA, but, well, clearly these things are really temperamental, that if you get voltage issues, it can just corrupt the firmware. I don't know. I wiped off the print on that side there because it was all runny and everything. It just looked a mess anyway. So, well, I kind of feel positive again now. I'd say I was so cheesed off with this thing, but, well, I mean, I still haven't fixed it. Oh, this is the thing. We've just got the screen back up, the display there, but nothing on the TV. That's the bit that's irritating the heck out of me. Why nothing on the TV? In the meantime, I'm going to do the mod to this to bring this update the firmware to 1.12, which is a pretty recent one. Putting it in line, I think, with the OSSC Pro. I'm not sure what features the Pro provides this doesn't, but anyway, to do that, you move this resistor here. Well, you just remove it. I'm going to move it, I think. And so it's only one pad, and then to the bottom pad you solder a wire and you go to pin 25 on this IC here, this corner pin on that side, because pin 1 is on the left and there are 25 pins on each thing there, because it's 100 pin, I think. I may even count those, yeah. But anyway, it's, as I say, this wire from this corner pin here to the right hand resistor there at the bottom pad. You need to remove the resistor though first. So, I'll have a go at that. If you get sufficient, and just do that, there we go, it's off. There we go, that's not bad. Can't believe I did that with my, using the hands the wrong way around. That's pretty much it. So it doesn't look especially clean with the magnification because, well, we've got you know, the plastic has melted a bit. So let's just now revisit this here, this wire down the, you can't even see where I am here. There's some flux there, look. That needs cleaning. So let's just move the wire over there. Yeah, and then it just curls down around here and comes over there. So that's all right. I think we just need to clean up though, don't we? So the final part to that is to go and apply 1.12, which gives me an opportunity to show you how to program this up with a USB blaster. Anyway, that's our mod in place. So I hope I got the right LED. Yeah, and it's going to pin 25 here. That looks correct according to the forum post. I don't like that crystal. I'm going to straighten that crystal a little bit. Like that. It just looks better, doesn't it? It just looks better when it's straight. And we'll get some UV solder mask onto those things, but I will give it another clean up around it here with a toothbrush before we do that. So, the JTAG connections are here. And as I say, we need a USB blaster. So here's the one I modified earlier that came from Mike T. So we'll just plug this into there. It's keyed, which is nice, can't go wrong. You can use a Raspberry Pi, I think, to do the same thing, but then you can't use the software we're about to use. You'd have to do it in Linux, you know, with the Raspberry Pi or something. Anyway, let's go over to the PC. I'll plug this in. It gets detected as a USB blaster. I'm not covering how to install the driver or the software, but I'll just show you. I'll open the version of software. It'll connect to the device, and then we just add a file. Tick a couple of boxes and click start, and that should be it. So hopefully you can tell from that, that was a really painless process. It took no time at all. And that's the only way to unbrick one of these. If you've got one of these where the display shows nothing like mine, just a backlit screen with no text or whatever, or it's, you know, really glitching out, making you think maybe the firmware's corrupted, that's the only way you can unbrick it. Because if you can't get into the menu and choose update firmware, you can't go via the SD card, you know, the micro SD slot. Dave Poo 2, check out his channel. He does various Amiga videos and things, occasional upgrades and mods, lots of gameplays and things. Well worth checking out Dave's channel. He's a supporter of the channel as well. Thanks ever so much, Dave. He did a video recently using this. Yeah, so you can write one of the binary files, because there's two different files. You saw the type of file I attached when I programmed this up using the Intel software there, Quartus or whatever it is, but you can write a bin file, you know, it's the other type of file, to an SD card. You can't just copy it on, you've got to use something to image the SD card using the binary file, I think. It puts it in a specific place in the, you know, the file structure on the disk. And then you can boot from that, choose update firmware, and just follow the instructions, it'll update the firmware. But watch his video if you want to upgrade the firmware on yours and you don't have a USB blaster. This is just because I had one and I thought, it's bricked, what have we got to lose? I may as well see if I can actually see the chip. And lo and behold, it actually worked. After I did that, I had given up. You saw, and I genuinely had, I'd given up. I was really miffed, thinking this is pretty much the first thing on my channel I've had to give up on. And I didn't have to give up on it, but you know, the point is when you've got so much expenditure and I think I did have, you know, it looks like I was going to have to spend another £60+ on parts and then no guarantees. That just seemed like a crazy idea to me, but you know what? I think we're there pretty much. If we get this chip here for the HDMI, fingers crossed, we should get HDMI again. And we'll switch it on together, see what happens. Yay! 1.12. Fantastic. And if we hit the menu button, let's just see if it's actually doing anything. Should be. Menu. Yep. So we can get in and out the menu. Fantastic. I tell you what, it's a good idea to reset settings when you've done a firmware update. Okay. Done. That's it. So I'll press OK again. I've done it again, I think. Yeah, so at least we know the firmware's been reset, the settings, as well as updated. The only other thing beyond that chip, hopefully that'll fix it, the fuse and a bit of UV solder mask in a few places, as well as a clean-up around there, just to make sure I've got rid of all the flux. I'm sort of half tempted to tip this into the ultronic cleanup up to the point of the LCD here and clean the bottom half of the board there, try and avoid these heat sinks if I can, but well, it's a bit difficult. And obviously get the heatsink back onto the replacement chip there. So let's get the HDMI in there, switch the TV on, just see if it's any different. I doubt it. I seriously doubt it. Yeah, so the TV's on HDMI 2 and that's correct. That's where the cable is. But yeah, still no display. Ah, that's what I get for doing mods when I'm tired. Did your work out? Stuck in the wrong place. So 4 or 5 days later, I got a chip here from the amazing Philip Bryden. Good luck, Chris. Phil, thanks, Phil. You're an absolute star. I didn't want any money for this.
I'm expecting to find an OSSC.
Not even for the shipping, which is just incredible. So I'll send something to him at some point to thank him for this. This is that. Oh, I can't see how the SD bag works. There it is. So wrist strap on. Let's try and get that out on the table. So it's looks like brand new ITE chip here for the HDMI. I don't know what it's classed as. It's not really a HDMI retimer as the people call them on Xboxes and PlayStations, but it's a similar kind of thing. It converts various video formats into HDMI. And it's manufactured by ITE. The part number is IT6613E. We'll have a look at the schematics in a bit, if we haven't already, and I'll show you some of the things we've done and where things are on the schematics and how simple the schematics are and, well, how complicated in places. So we need to get this heatsink off here, don't we? This is going to be fun. It's not coming off, is it? Oh God, that thermal adhesive. IPA obviously is a thing, but do you know what? I want to try and stick it back down. I might be able to actually reuse the glue that's on there if I can get it up. There we go, it's coming up. Yeah, stick that back on the case with the other one. The thermal stuff is in good condition, so it's like it can stick back down is the point. You can see there's none of it on here, no residue. Anyway, I'm going to use the low melt solder again. Did we have this problem with the last one? I don't remember. I don't think we did. Now it's coming up, look. There we go. Just carefully flip it over. Put it down like that.
Close my eyes, embrace the black. Sleepless nights and headaches stack. Restlessness to hell and back. What's my purpose? What do I grab? A slippery surface, a heart attack. And sometimes you just gotta believe there's something that'll give you relief. There's something that'll have what you need, what you need. We're broken, it's tragic, we're not all elastic, but maybe there's magic, believe you could have it. And I know of sadness, the anxious and panic, the infinite vastness of all that is blackness.
So I'm going to connect the power up. I'm just going to put a finger on there. And switch it on, finger on it. Switch it off. Did it have an error? Inner error, -4. Oh, God's sake. So -4 means, well, a new fault. It's got to be something around here, hasn't it? Yeah, if you couldn't see the screen there, trust me, it said in error -4. Yeah, that error message is the initialization of this chip. Just looking at the old one, just check the part number, is it right? IT6613E. Yeah, that's what we got fitted. Right, I finally found a short. Pins 19 and 20 were short. That's this corn down here. And I measured, short. Ended up using braid. It was probably like a really large clump of solder at the back. That's one thing you've got to be careful of when you get too much solder. So it's coming up with the display here properly now. I've connected HDMI. It's on the right channel. Let's just see, does it actually output any video now? I'm just going to have a look at the display. Yeah, it's on, but nothing on the TV again. So there we go, it wasn't that chip. It's the FPGA, isn't it? Hang on. Oh, now it's working. Why didn't it come on the first time? Hang on, I can't switch the power off now. Oh, you can. I'm confused by that. Oh, God, I'm so pleased. I've spent so long reflowing that chip. I've been at it for like 2 hours. I think if that was on a terrible fireboard and I was building it, it'd be easy. But because the chip wasn't completely flat, and because there's no clearance, it was just trauma replacing that chip. Wow. Finally we have video. Now originally I was going to offer, I'll still offer to send it back to Jamie, at the cost of the parts I've had to replace. Yeah, alright, I bought the screen, but you know, it's just part of the repair, isn't it? It's like, these are the things that happen. You may say, well, that's not right. If someone sent you something to repair and then you broke something, you should be paying for it. The point is here, he gave me this. So here, Chris, you can have this. So it's now mine. Yeah, so if I'm going to offer this back to Jamie if he wants it as a spare, then I need to recoup the costs at least, you know, because I've spent considerable time on it. I'm not charging Jamie for that. So I'll offer it to Jamie at the cost of the few parts we've replaced here. But, you know, I'll be honest, I'd like to keep it if I can. And if that is the case, I'll give him the option. I'll say, Jamie, look, I'll give you some money for this. I don't know, maybe 70 quid or something, which is cheaper than an OSSC would be. Granted, I'm pretty much there, all the way there to buying one with the parts and the time and everything I've invested in it. The point is, I'll give Jamie the option. He can have it as a spare at the, I don't know, 30, 40 quid, 40 quid-ish, isn't it, roughly? Parts I fitted. Granted, that came from Phil, the amazing Phil Bryden there, so I haven't had to pay for that. That would have been another, I don't know, £10 to £15 probably. Yeah, it'll be like the 50th clean this area's had. Look at all the flux around there. I haven't even cleaned it off before testing. And in a controlled way, because the screen will get knackered if that goes in there. So I'm going to put this half here, because the flux went around the buttons and everything there. It's just right in there. It's under the chip, all around these components. So I'm going to submerge this like that, and switch it on. The worst part of this, you may think was breaking the screen, but it was soldering that. That was an absolute son of a you-know-what. Son of a board is what that was. And 480p, yay. So let me hit the menu button. Ah, yes, we get on-screen display. Oh, fantastic. I need to connect something up, don't I? I'm going to connect up the TF-MSX, I think. So I'm going to, I don't know which switch on first. Let's put the OSSC on and let's connect this. That's on. Yeah, we're not out of the woods, are we? Because we're not getting any video. It's identifying it as 260 something p, but then why is there no video? this is on. Hang on, we've got a display now. I don't know what happened there. It just mysteriously came on. That is HDMI, isn't it? Yeah, it's got to be, because there's nothing, no other connection. So we've got sound and video. But why did it take so long to come on? I'll change the channel again. I'm going to change it back. Right, that's MSX. So just leaving it there now. See how long it takes. Oh, 48p. Yeah, so it is working. Oh, hang on. Oh, it was working. It's coming and going, look. Why is that? It might be the stuff it's doing with the display. Like the sync is like changing a little bit at various points and then we'll lose the signal. Let's just leave it really like that and see what happens. As it goes around the demo, do we notice any issue there? Look, it's gone again. I actually think it's... I was going to say to do with screen mode, but I don't know, it's coming and going there, look. There's an awful lot of comprehensive, settings and things you can tweak as well with the OSSC. I mean, it really is comprehensive. The volume of, the number of settings you can actually adjust. So there may be something that just needs tweaking a little bit here. It might be like the sync level is marginal with the TFMSX, the way I left it on the video cable. Solid now though, look. Don't know. Maybe as it continues to run, it stays, sort of locked on better, I don't know. Seems better now, doesn't it? That's an interesting one, that it's like it's warmed up or something, I don't know. It's bizarre. It's great though, and we've got the sound as well, which is fantastic. Gadget, that's 1 degree off in terms of accuracy. It's not quite as straight as it should be. I don't care. No one's going to see it. It's going to be inside the case. If you're losing sleep over how crooked that fuse is, please don't subscribe. Like that. Knowles Retro Lab Special. There we are. Yeah, there are a couple of scuffs there. But anyway, that area's alright. The fuse is on. And yeah, try and avoid touching the screen again. Now let's rotate this way around because I'm going to break the screen again. And a little bit of black UV solder mask. There, that'll do. And blast it with Cat P light. You can see it's violet. Yeah, ultraviolet. Small amount like that, it's not going to take too long. The bit there's started to dry, and I put a little bit there. I just moved this wire out of the way, but anyway, I had 10 minutes or so, 20 minutes maybe, with UV. I'm just going to just pull that back this way, like that. That's it. So that's that wire. Yeah, there's a little bit of flux around there still. Yeah, look. Which is interesting because that end of the board went through through the ultrasonic cleaner. It's like, how does that work? Put it through the ultrasonic cleaner. It didn't get all of the flux out from under that, did it? So I'll try and line it the same with the other one's line, like with the lines going down like that. And of course it's easier to do things like this not under the microscope, so you can see what you're doing. Like so, let's just press that there quite hard, just go left, right a little bit. That's going to hold on there. And this one, you can see I stuck these on here just because then you wouldn't get dust on it. And well, hard to get off again. And get the one on here. And just needs a little twist that way and press. There we go. So we dealt with the fuse, we dealt with the solder mask, we've got the 3 heat sinks back on. I'll just make sure it's working and then I'll get it back into its shell. Yes, there'll be a link down below to the GitHub for the firmware. Yeah, but the AI in Google brought me back this. I did find previously a more comprehensive list of init error codes, but yeah, the 4 main ones that have come back here from AI, yeah, they seem accurate from what I can remember. So init error 1, flash memory error. Yeah, init error 2, video amplifier failure. We haven't seen that on this one. We did have init error 3, video digitizer failure. Systems cannot read them from the TVP 7002. So there we go. That's what happened when that 7002 chip was missing. And we did see towards the back end of this init error 4 HDMI transmitter failure. So it's good that those error messages seem to work. And the point there, if you missed it, when I was reflowing and stuff, I worked out 2 pins were joined together. I think it was 2 data bus or address bus connections actually on the IT6613. Things vary a bit with the OSSC Pro because there's a Pro, and I think there's an OSSC 2, I'm not sure. But anyway, take a look at those links down below. And you can see the OSSC is really comprehensive in terms of the settings, the capability. There's just so much configurability within the OSSC. And that's one thing that could scare you off a little bit, that you've got to do an awful lot of fine adjustment depending on what it is you're trying to, display on your HDMI output. VGA, from what I understand, is a bit hit and miss, and you've got to really fiddle with the settings to dial in according to whatever your VGA source is that goes into this device. So we may look at it more in future videos. The bottom line is it's kind of out the scope of this video. It's so complicated, believe me. I think you can download profiles that people have created online. Those can be on you can put a little micro SD card, as I showed you earlier, to update the firmware, but those little profiles can go on a micro SD card in the front of it, and that could just make things a little bit easier. You could download a profile for a SNES or, I don't know, 3DO or something like that. Yeah, and the final thing here, and I corrected it with annotations before, contact cleaner in there, fix the HDMI, but let me just show you. It's working at this point here, but it wasn't a minute ago. And I've noticed this with this cable. If I just move this a bit, I'll show you on the screen. All I did is just touch it. So it probably needs a new connector maybe, or a new cable. This is my cable I've had for years. It's like a monster HDMI or something that we won. So you can see that I do have this problem. Let's try it on the TV side. It's not the TV side. Oh, there you go, 480p. So yeah, that was the issue when we first tested it with the MSX. So just make sure it's off. Yeah, it's off. Gonna just get some contact cleaner in there, like that. Slide this in and out a few times. I think it's a dirty connector. Now we did ultrasonic it, but you saw what happened with the ultrasonic. There was still flux on the board afterwards. Because, yeah, the ultrasonic is, well, I think they vary in terms of the power, how well an ultrasonic cleaner can work, and getting in and out of a cavity like that, it can be quite hard. I bet that's it. I bet there's like some flux around there, maybe. Yeah, it came straight up there then, first time. So if I try that again, we'll switch it on and then I'll unplug it. Yeah, 480p, that is much better now. Unplug it, plug it back in. See what happens, straight up. So that's what it was. that issue with the MSX thing towards the end. But that was not the issue we had all the way through the repair. There was no, you know, I did this, I sprayed it with this right at the start. I tried a different HDMI cable, I tried it on a different TV. Yeah, so it was ultimately the HDMI chip, the 7002 chip, the regulator. It lost the firmware as a result of probing a clock pin on a crystal. Go figure, that's a really weird one. Yeah, so massive thanks to Jamie Morgan and massive thanks to Phil Bryden for the chip. So please check out the two channels down below. The interesting thing, by the way, with that, when I was scoping it, and I mentioned it before and I perhaps didn't explain, but when I was probing, I had the scope here in my hand and I touched the clock pin and my hand was just touching something on the board here and I felt tingling going up my arm, and it felt like, I don't know, over 30 volts, potentially AC, because it was tingling. It wasn't like DC. So I think that the problem there was the fact that my scope wasn't isolated from the mains, and I think that I had a mismatch. It's a bit like what happened with the A590 when we tried powering that from an ATX power supply whilst we used an Amiga power supply switch mode for the 500 itself. I think you get a mismatch if you're not careful. And when I was scoping the clock pin, I didn't have the ground connection on the ground on the board, which means you are going to have a difference, you know, in your things. It may have killed the scope if I joined the grounds up. I don't know. Post your comments down below. If you ever blown a scope without an isolation transformer, please explain to me what you think. Was I lucky? Was I unlucky? How did it lose the firmware from that? I don't know, still don't understand that. And the final thing I'll say here is, yeah, this is recessed a bit, but if you were to just dink this a little bit in one or two places there, it'll crack really easy. So I'm going to try and get a clear piece of perspex or something. I'm going to stick it on the front there onto the actual bit there, maybe stick it on the top so it just overhangs. Anyway, that'll be in another video. And obviously got a lot of testing to do with this because there's so many things I can use it with, but it's so complicated. Anyway, hopefully you found something in that video interesting. Yeah, check out the video when it goes up there for the adapter we used to program that, because I had to do some modifications. Thanks to Mike T for that. Anyway, if you'd like to support the channel, please see the Ko-fi and Patreon links down below. I'll catch you in the next video.